So John and I had a really interesting call yesterday that I wanted to tell you about. We spoke with this guy who has a YouTube channel that I'm a big fan of. It's sort of a maker's YouTube channel, and so we're trying to see if he can do a show about what OpenEEW, and so he was quite interested. So I think the next step is for us to provide him more information. Vaclav and I are talking to him again tomorrow, right? And we're going to, or Friday, I can't remember.
I think Friday.
Friday.
Unless
and he's a really technical guy, so he really wants to sort of dive into why MEMS accelerometers can be used for earthquakes and sort of get an understanding. And I think it's a great opportunity because he has a lot of viewers who really fit our sort of particular niche. So I'm quite excited about that. He also mentioned some really interesting ideas, which I've been following up on. One of them is potentially using a different accelerometer for some people, which was a discussion I think we can have. And another one is trying to find ways to reduce the cost of the overall board so that we can, attract more people to the project. So they were both very good ideas.
Guys, I swear to God, these meetings are cursed because every time there's a meeting, the RIM has an outage. So there's the 560 million users are down again.
Are you whispering at us?
Hey, Johnny, you're a little bit quiet. We can't hear you that well.
Oh, it might be because I'm on a Mac now, so.
Okay. You can run React or you can listen to the TownHall. You can't do both. Sorry.
Microphone is set correctly, though. I don't know what's going on.
Yeah, you might have to bump up your input. I had to crank up my volume to hear you. But, yeah. What were you saying?
I was saying that the meetings are cursed because every time there's a meeting, the Rhythm has an outage. The thing I code for, it has an outage every time there's a meeting. Coincidence? I think not. Anyway, let's continue.
Well, just to finish this point, I wanted to sort of ask you guys what you thought about this idea, because I got quite interested and I've been playing around this morning with it, which is that we could have a variant of our board. I mean, Neil, you've got some experience in these things as well, but we could offer to people a variant which they could build themselves using AliExpress parts, which is basically an ESP32 and a sort of a cousin of our ADXL, which is not so sensitive. So the question I would have there is, do you guys think that's interesting? But also, do you think, Vaclav, perhaps that this could be useful? I mean, whilst it wouldn't be detecting as often, it would be useful if there was a large earthquake.
Yeah, I will have to check out the noise levels, but for sure, yeah, even when it's less sensitive, like for the large earthquakes, it should be still enough. Accelerometer cell phones would be good for magnitude 5, 6s. We should probably we would have to be careful in processing because it might have slightly different ways of processing that, but maybe not even that. But yeah, for sure, yeah, that would be definitely useful. The better, the larger the density of network, the better it is, and for those large earthquakes, as you say, even less sensitive sensors work.
So just an idea on that. I mean, in thinking about my situation, just how I'd like to put the sensors, I mean, I think there's a place where the sensor, I'm thinking of it, goes, but then there's a place also for an alerting type system. So this could fit into that where it's much more in a common space. And in this case, I'm thinking, gee, well, maybe I want one in my my bedroom, basically, to give me that alert at night. So something that could be more of an indicator, a more gross indication, could be useful.
So are you saying then that sort of the less sensitive and cheap accelerometer could be bundled with more of an alarm system, so that it's primarily an alarm, but it also has an accelerometer?
Yes. So that's the thing that I'm looking at now is that, hey, if I want an alarm system, or one that's an alarm, then this could also perform that function.
Right. Okay.
I think that's not a bad idea at all. I really like this one because people will be motivated to get the alarm systems, and I always it's a problem to have a sensor and the alarm system as we sort of have. But the problem is that, or sort of the problem is that we wanted to have it deployed somewhere where there are no people, and the alarm system needs to be somewhere where there are people. But like the alarm system, like if there is like a cheap accelerometer in like paramilitary an alarm system, for example, the one that you got, Andy, for Grio, like if that contains, this one, if that contains like very, very cheap accelerometer just for densification of the network, like if it will increase the number of sensors tenfold times, it's still going to provide very useful information, even when it's like $1 MEMS accelerometer.
So I love this idea, and we have sort of done it with this. This one does have an accelerometer, and we have used this to sort of harvest accelerations from people who have this device, which are several thousand. The issue is what I got excited about there yesterday when this YouTuber was mentioning this notion of having an alternative accelerometer was that we could enlarge the people contributing to our firmware and PCB without having a different design completely, but that they would just be basing it on a slightly different, maybe in the same family of accelerometers, but it would be a slightly different version. I just like the idea that it would be the same product almost, and that the maker community could embrace it without having to work on a completely different product. Because I think that there's appetite for that. I just think for asking people, the average person, well, all of us, $100 is a lot of money, but asking a maker who's not primarily focused on earthquakes to fork out, $100, especially when you go to some of these rural places where, that's a significant portion of someone's income, is a bit of a concern. If we really want this to sort of scale.
I think the other thing you can look at that is if it's on a structure, high up on a structure where it can be more of a visual presence, it's going to the structure is probably going to amplify something. So maybe is there a better way of talking about it not being strictly a sensitive earthquake sensor, but more of a visual alarm device with some basic sensing in it? I'm just throwing that out.
I don't know. Raka?
Yeah, this definitely would be an issue if people deploy the sensors in, second floor or so. The amplification is going to be there, and it's definitely going to screw up somewhat, or bias the algorithms. I think that there's probably, there's more things that we can think about and that can potentially enhance our data. Also, I think that if we have, for example, an alert app, we can also include grabbing a piece of acceleration data from the cell phone in case that there is some kind of alarm, and we can use that acceleration data in algorithms. Or if we have that alarm device, we can also include that and use it as a less quality data. I would probably see all these things a little bit down the road, but I think that we should probably think about all potential sources of acceleration data that can densify in the network, because I think it's very important to have a good quality network of relatively high quality acceleration data as we are building right now, but densification in future is equally as important. And I think that 10 years down the road, there's going to be so many devices that will be connected somewhat like IoT style, and they will provide so much of acceleration data that our networks are going to be more like that high quality backbone of a future system, which is going to be densified by all the smart fridges and cell phones and everything. So we definitely need to think about these things, how to enhance our relatively high quality data with all this low quality data. But maybe I would see this a little bit down the road, not part of the.
But in the short, so thinking about this YouTube, sorry, I keep coming back to this, but I'm quite excited because he has videos which get 600,000 views, so we have an opportunity to get 600,000 makers involved with our project or portion. But so he's talking about doing a video in a month's time. and we're going to convince him to do this, hopefully. But the idea there is he wants to talk about how our sensors compare to other sensors, and how his community can get involved. And he wants to offer them, you know, a sort of more DIY option for some of those who don't want to spend $100. And so you know, I ended up prototyping this thing, and I've actually just got it to work. And it's going to take some work before I get our existing firmware to work on this, but I don't think it's going to take me too long. And I just thought, you know, for, you know, in total $10 from AliExpress, someone can have this as opposed to 100. And whilst it's not going to capture all the earthquakes, it is a proof of concept, and it is a useful node within our network. And it is a way for people to contribute to our code. So I was going to persevere with this. I'll let you guys know how it goes, but I just see there's an opportunity to expand our group beyond the affluent people.
Yeah, I like that idea. Overall, I think that's definitely a step in the right direction. And as you say, that's a giant community and large number of people that can do this. So yeah, definitely, I think we should do that.
Yeah, agree.
He also mentioned LoRa, because he's really into LoRa, and we had the same discussion we've always had about the restrictions on LoRa, and he has some ideas there about how you can get past the frequency of sending messages. But there's still the idea that LoRa is really good for, like, you know, mesh networks in rural locations. But if our sensors are 10 kilometers apart, we're starting to stretch the definition of what a point-to-point system can do in LoRa. So again, let's table that one for the future. But it was a useful conversation. So enough about my call with a YouTuber. Anyone want to share anything?
I can give an update on the dashboard if we're there. Yeah, so we were talking in the dashboard meeting on Friday. I just from what I said on Wednesday that I was going to give myself a time limit on some of the deployment stuff, and if I didn't meet that time limit, I was going to kind of put that stuff on the back burner and then go to the more immediate things to work on to hit our, you know, end of May date. So I'm on to trying to figure out how to connect the MQTT to the node back end. Hopefully, I'd like a lot of that stuff to at least look like it's going to be, you know, to be, let's say, at least making the connection by the end of the week, and then into next week, hopefully get some of the data visualization charts and whatnot going on on the sensors page. But it's such a critical part of the dashboard. I figure we probably shouldn't wait to add that. It's also somewhat of a complicated piece because I don't know how well MQTT is going to talk to all these components just yet. But that's what's new in the dashboard.
Are there any references that we can use, or people using MQTT to talk to dashboards? Are there any examples that you found?
Not that I saw, but I talked to John about it, and you know, he was telling me that there's basically two different. You can link up directly to Watson IoT, or you can do it through the MQTT library, which is a little bit more manual, but is what he would prefer for. I think because it's a little bit more manual and a little bit more configurable. But you know, it sounds like he's had experience at least hooking up to Node, or a decent amount of experience doing that. So I'm going to just sort of follow his, you know, guidelines for it. And I think he was going to, excellent, put myself on mute, you know, just sort of some sample code of how he's done it in the past. But then once it gets to the Node backend, the way we get it into React is that's pretty standard stuff, because by the time it gets to the server side, you know, it should just be normal JSON that we can then pull for using GraphQL and hopefully get that, you know, near real-time effect on the front end.
Can I make a comment about this? So yesterday we had our seismology meeting with Adrian and Vaclav, and we discussed architecture as well, and we talked about MQTT and some other ideas. And one thought is, can we perhaps leave it slightly open as to whether, you know, down the road we will always use Watson IoT, you know, because we've talked about this becoming open source, but nothing is certain, and you know, there is a huge bump up in cost after 500 devices. which we probably wouldn't be able to support. So if we could just leave the door open for another type of MQTT system if necessary.
Yeah, so that's maybe one of the reasons why John was mentioning to use the MQTT library instead of directly the library that connects directly to Watson, perhaps among others. But yeah, I think in using that library, it's at least a little bit agnostic, right? You still have to write the code, as far as I know right now. You still have to write the code that connects to that system, but it's just a little bit less dependent on specifically the Watson IoT library.
Could I just ask, how do you think this scales? Because from what the discussion is, I mean, that's always an issue. Is there's a breakpoint, and where do you think, if anything, how you would test those breakpoints?
Well, from the are you saying from the dashboard perspective, or from the perspective of adding new sensors to the system as a whole?
I think it's both, really, but adding new sensors, especially if they are likely to be low cost, sort of multiple, scalable, then just what happens when somebody does promote it and you get 1,000 added?
Yeah, no, it's actually it's really one of the key questions at this point, because we're building things right now with only a little bit of test data, right? Only a few sensors in the system, but we're hoping that this expands to thousands and thousands of sensors at some point. As far as the web development side of it, there are a number of things that we can put in place. I mean, there's caching, there's using Redis, which Adrian, I think, talked about at some point, to cache some of the data that is frequently used, or at least frequently called from the server side. There's also ways that within building the dashboard, we can specifically pull only for a certain amount of sensors at one time. I think we already decided that we really can't have real-time data just constantly flowing into the dashboard and be able to handle that from thousands and thousands of sensors. So we have to make it so that at this point, if you want real-time data, it activates that subscription at that time for one sensor. It gives you about 30 seconds of an acceleration stream, and then you have to do it again to get more of the real-time data. There might be a better way of doing that in the future, because as seamless as we can make it look for the user, probably the better. But yeah, those are considerations, because when you have hundreds or potentially thousands of sensors added to this thing, I mean, the raw acceleration data is just an amazing amount of data to be able to be processed by something like React, or something that's not some sort of big data stream or something built for that. But then there's also the potential caching on the back end. But yeah, I think it's just increasingly getting more into technologies that handle big data, as opposed to now, which we're just kind of at the point where we're using basically kind of beginning web technology that handles kind of a few use cases, and then I think we'll eventually get into more tools to be able to handle large amounts of data like that.
Right, because I mean, there's something also where you can put in the how long does it take for it to process something. So therefore, you can, to some degree, if you're seeing that you're going to have 2 or 3 context switches as it comes through, then that sort of can scale, or you've got some numbers that can scale. But I know I'm just on the outside of this. I know I've been on systems where it's hit breakpoints. Monitor My Watershed right now is sort of on that level, and it's better to try and do it in the beginning, if at all possible, than it is to sort of try and retrofit it.
Yeah, I mean, absolutely, because one of the biggest problems I see in projects that I work on is that developers test with like 4 things in the database, and then all of a sudden, it grows and grows and grows, and the technology that would handle that growth wasn't built into it from the start. So yeah, it's definitely one of the key things that we're looking at now is just when to, I think is what you're talking talking about a second ago, is just how often to poll for new data, right? Whether that's 2 seconds or 30 seconds or 60 seconds or whatever it is. We'll have to tune that over the next few weeks to try and not overload or, run out of, have your browser run out of memory when you're looking at the dashboard with all that data coming in.
Can I make a suggestion, which is, if we can try and predict what sort of loads we're talking about here, or how much new data there really would be, because let's just imagine we had 10,000 devices, which ideally we will get there one day, and let's say that each of those devices, because of the firmware and the fact that there's an algorithm running, would only trigger, let's just say, 1 out of every 1 day a year, which is actually in itself significant because it might only be a few minutes. But let's just say, so I just quickly worked that. That's about 28 devices per day, if my maths is right. And so is that right? I'm not sure. But it's not a significant amount, if you know what I mean. It's not huge amounts of. It's not. I don't think we're in big data territory yet. And of course, the threshold we can really raise on the algorithm as well to filter out.
You will have a lot of triggers from those low quality sensors if they are deployed in room, when people live, and if they sort of work as an alarm tool, or even if they don't, and people just have them on the table or like in the room where they live, I think we might have quite high number of false triggers. Like the number of earthquakes is going to be very, very low, but the number of STA LTA triggers is going to be quite high. But I don't think that this needs to be a problem, because I think that if we have sort of lower quality sensors, we can also do pre-processing on those sensors themselves. It doesn't need to be on the trigger. It can be just like pre-processing. It can calculate, it can send us just the timestamp when it triggered, and sort of do some math that helps us with the, just pre-process data. And it's a few bits of information that would be very helpful to have from those sensors, but it will be almost no data, zero.
Like a peak accelerations.
Yeah, what the algorithm is doing now is that because the acceleration is not as indicative of earthquake magnitude, but it does double integration to displacement, because if you integrate twice acceleration, you get displacement. So the peak displacement in the first second, 2 seconds, or up to 10 seconds, that's indicative of earthquake magnitude. So it can do this math. The sensors can do this math probably quite easily in the firmware, and then just send this information. So it would be every trigger. It would be probably 10 messages, because we want to have an update every second on this value. But that would help a lot. That would be a significant.
So that sounds like a good way. And then another thing we had discussed many months ago was, couldn't there be something sort of within the MQTT script that we've been creating, something which just turns off a device if it sends more than 2 messages a day or continuously? That just we know what a bad device looks like, right? We can assume that there aren't that many earthquakes, and we just turn it off, and that's just going to reduce our bandwidth considerably.
Yeah, that's
well, the
true.
bandwidth peak. When you actually have an earthquake in, say, Puerto Rico, all of a sudden, all 100 devices will start sending up to the server. That's when you're going to fall over. That's when the dashboard is going to freeze. So what are we doing about that? How do we cope with that?
Well, I think we can simulate that pretty easily, because the thing is, everybody is connected to each other through MQTT. We have some simulation scripts that take some of the old data and then puts it into MQTT for the seismology algorithm. We could theoretically bump that up to scale and say, all right, pretend that there's 10,000 devices at once sending information into MQTT, and then it'll eventually get routed to the dashboard and the alerting system, et cetera. Because the key piece is that MQTT part, holding the data where everyone grabs. So pushing more information into that would test the limits of every component that subscribes to MQTT, which I think is everything here.
Yeah, and also we have to remember that anything with the dashboard, at least, is really based on user interaction. There's not a lot that's automatically going to be sent to the dashboard, at least, but the seismology scripts, yes. But the dashboard, we have to think about it in terms of, okay, when are users going to go to the dashboard, and are they going to start requesting a bunch of data from the recent earthquake that happened? And we were talking about this in a call, I guess last Friday, is like when we would expect the most users to go to the dashboard and start making a bunch of requests for data. And it's probably right after an earthquake, right? Because everybody gets on their phone or whatnot and starts Googling earthquake near me. And at that point, yeah, people would be probably making requests for all the acceleration data of the last event and whatnot. And that's probably our stress point right there.
Yeah, I mean, that could probably be simulated too, because you have your APIs, right? So you could just, in theory, put a lot of threads up to everyone log in and grab data at the same time. But to your point there, are you going to let people on the dashboard get access to this MQTT data without logging in? Because that might actually make things a little bit worse in that same situation you just described.
Yeah, and that's another, I think by default, well, this is another thing we had talked about previously, is that who gets to look at real-time acceleration data from the sensors. So right now it's set up that you can't even access the sensors page without logging in. So I think that, at least in the short term, is going to be the way that it is. You can access the events, and the events can give you a waveform, but that could be where some of our caching comes in, because it's going to be the same waveform for the same acceleration data across all those requests. So we potentially cache that for the events page, but the sensors page has you can click on a sensor and see the accelerations coming in. So who has access to that? Even if it's still a lot of data, even if you you have to be logged in, but you can see everybody else's sensor. Meaning the way to really shut that down would be to have people can only see accelerations on their own sensors. And the next level up would be you have to be logged in, meaning you probably have to own a sensor, but you can see acceleration data on everybody's sensor. I don't know if there's if there's any thoughts on that, or you want to go one direction with it. I think from the dashboard perspective, I think we probably could organize it where you can see anybody's acceleration data and still be able to handle that. But I think we would have to start thinking about how those requests would come in and make sure we can optimize that.
Well, yeah, what you're describing, there's a impact to the actual infrastructure as well, because right now we have the dashboard on one cluster, right? And there's going to be a limited threshold on bandwidth coming in and data transfer. So we're going to actually have to do some scaling there. What that pretty much means is creating replicas of the dashboard. We could space them out into different data centers and what have you, all from the same cluster. We haven't really done that yet. Because there's some technical details that we got to figure out, like you'd have to do parallel connections to MQTT and Cloud and et cetera, and we'd have to deal with those problems. But yeah, there's an impact there, just as a FYI, which means for us, it means more things we need to manage, which is why Prometheus and the monitoring systems that we talked about earlier make more and more sense, because you have to have that when things start to scale.
If I could just relay some experiences that I've had with Grillo the last few years, everything you've mentioned is really important, testing and monitoring, because you only get a few earthquakes every now and again. So for everything that you try and do, you only get a few earthquakes. And when the earthquakes happen, it's devastating when you get things wrong. And it's happened to us. We've overestimated or underestimated the shaking intensity of the earthquakes. And this is your time to shine, because this is when everybody wants to know about OpenEEW, and you've only got one shot, and people will be ecstatic if you get it right, but they will be 10 times more angry if you get it wrong. It's like a sort of goalkeeper in soccer where no one cares about them until they let a goal in, and you sort of and it's not just Grillo, but I mean, it happened to the USGS with Shake Alert when they've got things wrong. It's happened to SASMEX and Sky Alert and some other competitors, if you want to call them, of ours. And I think, everything we can do to sort of, at least get the first detection right. We need to do it because it's going to be very easy to generate bad press after all the goodwill that we generated based on getting a bad estimation. A lot is riding on it, basically. Well, people's expectations are high.
I would think that, you know, this aspect of having some sensors that you could have in real-time mode and just running would be one way of testing out the server. So, you know, being able to have the server designate a group of sensors from a particular area as more sensors build in, and just designate them, hey, run for an hour with real-time data. That would give an aspect for the server. But I mean, my experience in all of this is you've got to have a prototype system, and you've got to have the sort of production systems. And then if you're looking at low-cost sensors, you really don't want the low-cost sensors being mixed in with the you know, the detailed stuff. So anyway, just my 2 cents there.
Yeah, it is an interesting question. I mean, we have so many sort of moving parts in this. We definitely need some sort of like end-to-end test of the whole system, and kind of a lot of it, right? I mean, you just don't want to test it one time. You want to test it enough times. I'm just wondering if you can build like machine learning models or something to simulate different types of earthquakes and things like that, or just use the real data. But what is the best way to, like, from the sensors itself, test an earthquake? Is it feeding the sensors data, or is it physically simulating an earthquake? Like,
I don't think it can be done through the sensors, because there's no way we can. I don't think that there's any way we can like really take all those sensors and simulate, like shake them.
Yeah.
Well, yeah. I have thought about buying a shake table in the past.
Yeah, I was just say shake tables. Yeah,
they're not cheap. They're not cheap at all.
We need a lot of them too, right?
Well, what we would potentially we could do is find a data set that already exists and then simulate by injecting that data through MQTT. So sort of follow as much of the path as possible, where we inject MQTT messages into the system and see how the algorithms respond and the website responds and so forth.
That's interesting because we know exactly all of those sensor locations and the timestamps. So it'd be easy to sort of simulate that.
Yeah, and we are doing this in Seismology algorithm. This is what we are doing for like 15 or 16 earthquakes from Mexico for the Grio network. So, but I agree that we definitely need to do this kind of multiply the amount of data. Like we like right now we have 30 sensors in there, and only a few of those always trigger an earthquake. But like, yeah, we want to test it out on 1,000 devices at the same time, and that's probably work for me to like simulate this data, because you know it is not too complicated, but you need to like shift them like based on the real travel time that would take, you know, from an earthquake to get to the station, and then like you can really test out those algorithms if they truly work or not. So like you kind of need to like do the like reverse math and calculate like what is the time shift of an earthquake, what would the amplitude would be. So like you cannot really do it like 100%. Like you can probably do it, so like you test out the algorithm, but it's not. It is somewhat complex, because then like the greater the distance from the station to an earthquake, like it's not only the amplitude that changes, but it's also like that displacement and stuff, as we talked about it before. So like we definitely need to think about like how to simulate this data like in a way that is at least,
or we just have to get enough sensors in, say, Puerto Rico. We'll have a high enough density, and you know, if those aftershocks continue, and Pedro, I don't know if they're continue, but you've had like a long series of 3s and 4s for a while now, and maybe we just learn over the first couple of months before we call it, you know, we could call it a burn-in system, burn-in time, before we call it a live active system.
Yeah, so there actually have been a few earthquakes felt. The sequence in Puerto Rico has continued. I'm going to link up the website of all the recent activity. so this past month. As you can see, there's a map on the bottom that shows like where most of the activity is happening, and it has continued to be in the southwest region of the island, as well as the Dominican Republic on their side as well. There's been a lot of activity, so I'm sure that if we deploy 10, 20 sensors in the next few weeks, we could probably test the system out.
But Pedro, they're pretty tiny, these earthquakes. I'm not even sure if they would trigger our system. I mean, anything 3.5 is the cutoff, so half of these are less than that. 4 is about okay, but you've got to be quite close to them. Like, I'm not sure these would be useful for our system. I don't know what Vaclav thinks.
Yeah, that's the thing. Yeah, I think that if we are like very close to these, like 3.5s, 4s, they would get detected, and if they are detected on a few sensors, like definitely that's better than nothing. But this is not really gonna test the capacity of the system if there is magnitude 7.5, because then it's gonna be it's a very different earthquake, and definitely many more sensors in that case is gonna trigger, and we need to stress the system, because that's, as Andy was saying, like that's our time when we really need to get it right, and like you don't get this. Like I think it almost might be like one and done, like because those earthquakes are not that often, and if we don't get this one right when it happens, so I think that like we need to find ways how to train or how to test the system for non-existent large magnitude earthquakes, and definitely we can find a way. But I don't think that we can entirely train it on magnitude 3.5s and 4s, although those are definitely the most common earthquakes, same as in Mexico. But we need to have a way how to test it out on like simulated much larger earthquake than that.
Oh, so question. I mean, we kind of, I think, switched topics here, because we were talking about scaling and kind of the throughput across the system. So does the data even need to be accurate per se to do that? Like if you said there's like 16 earthquakes on in the Mexico system that you're using for simulation. If we scale that up and turn that into thousands and then put that into MQTT, wouldn't that accomplish the determining whether or not Ryan's side could pick it up and every other piece that's pooling from MQTT could handle that much data?
Yeah, I think it will test out some components. It will sort of test out my seismometry system too, but not exactly in the way as I would like it to test out. But yeah, definitely we can find this way, and I will think about this and try to do something like this, because right now we have those 16 earthquakes, and some of them are quite large, but as the network wasn't so dense and there weren't that many instruments, we just don't have that much data. So, but we definitely can do something like that. And what you are talking about, Adrian, it would definitely help to test some components, maybe not all of them, but yeah, there's definitely a way. And yeah.
Yeah, there's sort of the testing what the dashboard can handle and what all the sort of how much just sheer bytes, right, everything can handle. But then there's also the accuracy aspect, which is, I'd imagine, more testing, it's testing both the seismology, but also if we start building alerting systems and whatnot, the alerting systems and whatnot responding accurately to the larger earthquakes and whatnot in a certain amount of time. We probably should open up another repo just for end-to-end testing.
Well, just as a warning, when we get to the alerting system, you're never going to please everyone 100% of the time, because people who live right over a magnitude 3 earthquake are going to say that was a huge earthquake, but it really wasn't. So it's a very subjective thing that we're getting into here, and I think the best we can do is just sort of be super transparent with our methodologies and educate people as to how we generate these alerts.
Yeah, you always I always like the Shake Alert, the reviews for Shake Alert on the App Store are always everybody turns into an expert in seismology, right? Right as an earthquake happens, be like, well, I didn't feel that at all. It's like, well, there's a lot of science that goes into this. I don't know.
Shake Alert, sort of 25 years in development. How many tens of millions of dollars from Congress, and how many hundreds of people involved on a daily basis, and they get it wrong.
Right.
But they haven't got the brain power of this community.
I do. So I'm taking this. I'm doing the certificate in machine learning. So if there's any, if you need like helps on scripts or anything like that, I'm looking for projects to do with if there would be any kind of like application to machine learning to try and simulate earthquakes or anything like that. Vaslav,
for detection, I can give you the data straight away.
Yeah, I would. I love that.
If you are interested, we can call later, and I will give you the data set. I trained one for the detection, but it still has some, it doesn't work perfectly. So if you want to give it a shot,
yeah, definitely. I would love to at least try to understand how that sort of side of things are working. Sort of my it's what I'm interested in these days, trying to learn.
I guess we kind of talked about testing a lot here, and that's important. I think everyone's on the same page. But are we looking to work on this or do this before the MVP? I mean, I don't think we have enough time to get it done before the MVP. But at least, when do we want to start working on this? Is the question, because it's going to take a significant amount of work. It's probably going to be one of the more complex projects because we got to simulate data, and then we have to write some scripts that actually poll the dashboard and all the other pieces of the subscribers that subscribe to MQTT to determine whether or not they're behaving well when we scale up.
So some of that's already in place, right? So we have created a script which simulates an earthquake and writes its MQTT based on existing data, I believe. I mean, that part we sort of more or less have. I don't know what the rest of it we don't have.
Well, the simulation has to get scaled up like to be thousands instead of just the amount that we have.
And it's probably an ongoing thing, right? I mean, testing is not, we could probably always just build better and better tests, try and figure out how to, work with more realistic data. And out of that could probably come things like, trying to figure out where to, testing where different sensors are, and possibly like some sort of ranking system of how good, some sort of weighted property for how good sensors are and everything like that. I mean, it's a whole side of the project that is probably its own thing, right?
Yeah, I think that like when we finish the MVP for or that part of the seismology and stuff, I can think about like how to simulate more data or how to sort of take the historical data and tweak them so we don't have 20 sensors but 1,000 sensors. Because that's definitely, and that will be probably the next step for me. And I guess that this problem would be seismological, so I can take that one. And I don't know when exactly it's going to be, but I hope maybe it can be before that.
Rather than simulate, can't we just take a data set from another seismological network and just translate it into our JSON format?
That's definitely one option. And I think the only thing is that if we want to be correct, like we should add the kind of noise that our sensors have. So, but we can like mix it up and but that would be definitely an option. And I think that this might be the best one actually.
Okay. So what else? So John, I was explaining to everybody our call yesterday, and the sort of the feedback we got, which was quite good about sort of making it more accessible.
So Andres has a pretty large maker community that's and it fits right into his space. And he was talking about the types of people that would be willing to go and spend $50 on a device. If we could get the price sort of in that range. He said there's over 80 seems to be a different market of people that, and like some of us, I'll easily spend a couple of dollars to go play with a thing. I won't spend hundreds of dollars to go play with a thing, but I'll easily put my credit card in to buy a part for $20, $40. And so I don't know if we can ever get our sensor down to that price range, but we would certainly open the aperture of a community of interested citizen scientists, and it's great PR for the group too.
Agreed. I had mentioned, John, so I don't want to repeat it for everybody here, but I mentioned creating a sort of dumbed down version, which I'm investigating. So leave it to me. I'm doing progress.
So we have to, we have to prioritize too. It's if we're going to make a dumbed down version, is it actually going to be useful? And I wouldn't promise to him that we're going to do this just because we want his video by a month from now. We can kind of tell him we're going to consider it, but not that we're going to commit to it.
Sure. I mean, it's definitely possible, and we've just discussed it now as a group, and there is like a sense of its utility. I think is probably not in doubt. It just means it doesn't trigger so often, but it would trigger for the big ones, and it would allow more people to get involved. But I agree that there is a time, and there are other things on our plate.
We all struggle with the squirrel chase the squirrel around the yard.
So Pedro, I want to just ask quickly, Pedro, if you don't mind, about Puerto Rico. I don't know if you're available soonish to sort of start helping us there. We have the devices there. We might want to flash them quickly if you or one of your students you mentioned were available, and I don't know how you feel about that. Just so we can start getting some data.
Yeah, I'm on call. So I think we have to set up a meeting with the Puerto Rico Science Trust and the Seismic Network. But I'm on call to be able to help with that.
Oh, great. Okay. Well, let me set up the call then. It's with Annie from the Science Trust, and we'll sort it out.
Sounds good.
So, let's definitely do that, because getting a reasonably close firmware, that way we know it's got the right certificates and so forth. But that really says I need to deliver it's somewhat of a 1.50 version of the firmware relatively soon. What I have in the project plan a whole set of open tickets. Some I've closed, some are pending closure when the branch merges. There's maybe 2 or 3 that are sort of important, and then some nice to haves. Like, I don't think I'm going to rework the colors of the blinky lights, or can I make it buzz a different sound? That's lower priority to actually making sure that the OTA works and the data works, and a couple other more important ones. So just tell me when, and I'll try to get us a version so that we can go flash.
Neil, did you sort out the problems with the connectivity that you were having?
I'm actually just trying them out now. John put up some debugging there for me, and I'm looking at it. So the sensor went through some resets, and it wouldn't come up afterwards. It wouldn't connect to the Wi-Fi network. That's what I sort of wrote up. So I'm just trying some of it now, and it is. But there's obviously an edge here that if we see that it doesn't connect at any point, how do you at least note that one not connection? And the issue really is if it doesn't connect 1 in 1,000 times when you plug it in and you have a general power outage and it comes up, or you're doing a group reboot of some sort, how do you note it? So I've seen a number of items, and I'm still learning the system where it wouldn't do it. So John's given me a little thing to check out with the passwords correct, but right now it's working, I think.
I do remember with this little device, which is also an ESP32 and it connects to MQTT. I remember that we found we got all sorts of weird situations with users where sometimes if it connects to Wi-Fi, but it didn't for whatever reason connect to MQTT, then that would throw it into some weird loop. Or if it connected to there was a number of different routes it could go where it would just stall and then just not do anything.
Yeah.
If it kept
There's a
trying to
state
connect to
diagram
Wi-Fi
where-
after like 10 times, it would just give up, or there was a sort of timeout function.
I put in, there was one case that was legitimate I had never considered, but in a real world, it probably happens often enough. So if there's a power outage in a building, and then the power comes back on, your board reboots like almost instantaneously. It'll be back trying to connect in the first 30 seconds or so.
Oh.
The trouble is, if it doesn't detect any networks, it throws itself directly into the smart config mode, and smart config just says, I'm waiting forever. And what in fact is true is that the Wi-Fi router is slower to power on, and so your Wi-Fi network might not be available right after that power restart. So what I do, I just added some code. So there's a timer, so it does smart config for 10 minutes, and then says, oh, I didn't get any smart config. Let me restart anyway. Maybe the network is back available. And then so it'll be offline for 10 minutes, or it'll just, the person was actually trying to use smart config. So I think 10 minutes is sort of a sufficient time. So that was a good little scenario.
That's good.
And then I need to test all of the Ethernet, Wi-Fi. I think I got that right. Last week I tested that a bunch of times. But I'm curious to see what Neil discovers. I've put some more debug in.
Right. So you reminded me that it was turning off the network and restarting was one of the conditions that was very visible on there and doing it. So right now it's working and it's printing out the password. Okay. But that's the but that's where, I mean, in my experience in the past with systems, the issue is you really want to have a definition of what is the core stable software for this, and then really try and thrash it a lot. And that there's that gray area. Is it really stable? And so there's a development mode where you're just really trying to get it, make sure it's stable, which I think then is making sure that you have all the use cases covered. So, in this case, what are our use cases that we're sort of doing? I'm just picking a few of them from a sort of, the way I want to operate it. But is Ethernet a valid mode? What happens when somebody brings in a box, just plugs in Ethernet and expects it to work? I mean, clearly something could work there, but we really don't want it to work. But maybe it has to demonstrate something. Then do you actually have a box that you bring in and you configure on your local network? This could be, if you've got a technician doing something, they would configure it locally, but they might want to move it to another Wi-Fi network in another building or distribute them and stuff. So can you set up 2 Wi-Fi networks? I don't know the answers to this, but what is the use case configurations that you expect people to come through? And then providing we stick to those use cases and nobody else wants anything more. So anyway, I throw that out there. What are the use cases? And I don't know them.
Yeah, yeah, there's tons. There's tons of scenarios.
Right. So how can we limit it? Can we limit it to a defined set of use cases for this? Because it's a very important part, that initialization. And it's, I've put in Honeywell thermostats that have failed because somebody else had returned them to the shop and then I got them. I've got a bunch of other devices that are running. So this was just fantastic, the way that it detected the Wi-Fi. I mean, it transferred it across to the OpenEEW sensor, and then it really, it did work. I think I had a problem in the database that I haven't really understood. Something happened.
Ryan, and I think I manually created a user account for you. Ryan,
Yeah.
Did we get any progress on doing like a password reset?
No, but the forgot password. So the problem I think that is not the forgot password is something we need to build in. But the problem I think that we have there is that if you the link that is generated by the dashboard backend, if you don't finalize your account, you'll lose that link, right? So if anything goes wrong or you don't finalize it or anything stops in that flow, you can't get back to it and you have to manually create a record in the database. So that's also something that is definitely a thing that we need to solve in the next, a usability thing we need to solve in the next week or two.
So I entered that use case because I always do a defined type of email with a tag on it, and I put it into the system, and it seemed like the app reset and reset on me. So I then went in and I sort of tried a different email, putting in a different email. So my box doesn't have a number on it. So I couldn't really try and track through there. I mean, it would be nice to have the MAC printed on here. Is that showing up? So I've got that and there's no MAC on it. So I couldn't even go back into the database to say, hey, what happened with my MAC? But anyway, just observations that I tend to break things to begin with. I mean,
that's why we love first testers that go and willing to break it with us. It's awesome.
Yeah, and that's not. Yeah, and that's not the first time that's happened too. It's sort of a thing that we need to figure out how to solve. And I don't know, John, I don't know what exactly the best way to solve it is with the dashboard interaction, because I could just regenerate that link I guess if you get to the point where you actually set up your account on the dashboard, you don't need the link anymore, so it's all done. So perhaps every time, even if you do have an account in the system, maybe it should still, but it's not activated yet, then maybe we should just always regenerate a new link.
That's the right way to do it.
Yeah. Because the links, the JWTs that are the tokens that are added, they don't work after you activate your account. It checks to see if you're trying to use a token to activate that's already been used. So it doesn't really matter how many of those tokens we generate. If they all point to an account that's already been activated, then you can't reuse them. So it's not a problem to just keep creating JWTs that way. So maybe that's
why don't you do that in the back end? I mean, I could try to do that in a Node-RED flow, but just if it's verified, don't bother returning anything. But if it's not verified, it's in any other state. I think there's an expired and pending of some sort. There's a couple of states that the user might be in.
Yeah,
it's just regenerate the token.
Yeah, I could do that, and that's not because that'll just be on the verification route. The only change on the app side would be, so you are getting a verification true. Or I guess it would all be fault because I guess I can figure out.
If you do it, I can figure it out. I'll do it. I'll either do it in the app or I could do it in the Node-RED intermediate proxy.
Yeah. I'll try and figure out the easiest way to do it on that route. But yeah, that's something I could do today actually.
Cool. Nice.
3 o'clock, guys. Anything else we should discuss? If not, back to the browser or electronics board.
All right, Neil. Let me know how you're doing your testing. I'm going to try to finish up the firmware in the next week or so that we can get that ready for Puerto Rico.
Wonderful, great. I just sent you a message with an idea.
Okay. Good. All right, I do have to jump to talk to my VP.
Okay, ciao.
Sounds good. Have a good one, everyone.
See you, everyone.
See you.